Today I will demonstrate to you how to use the Stroboscope interface. We created this interface using LibreOffice, and it can also be used in OpenOffice and Excel. This interface is user-friendly. It allows people who does not have much programming knowledge to modify the codes easily. At the left hand side, you can see the input. Pin 2 to pin 13, pin A0, A1. For A2 to A5, all these are for future add-on. The red pins are actually for the LCD, so we do not want to touch the codes. For example, if you put I, O, or I is actually input, O is actually output. If you put I, O, I, or O, any value, the LCD will not function, so we cannot touch the code here. We leave it empty, or the red one we leave it empty. There are two types of programming codes. There are two types of sketches. You can see that the Arduino sketches are actually easier to understand, but they consume more memory space, more processing power. Whereas for AVR code, with a mixture of Arduino programming codes, it's actually more efficient, save memory space. So we will be using mostly the AVR code plus Arduino programming. First, these are the default configurations. We will see which code actually consume lesser memory space. First, I will copy the Arduino programming sketch into this here. Do an uploading into the chip. You notice that the sketch is about 5170 bytes. If you copy the better efficient code into here and upload the sketch, 5086 bytes is lesser. So these codes are more efficient. Both of them function the same. Now I will demonstrate to you how to calibrate our stroboscope using this program. The serial output by default is set to off, so that we want to save more memory space when we are not doing calibration. Now we will turn it on because we want to calibrate our stroboscope. By turning it on, we have two options here, off. First, we will calibrate this. We measure the execution latency of LCD codes. As you can see here, measure the execution latency of LCD codes. What does it mean? It actually means that we are calibrating the time delay from... Okay, I have to turn it on first before the code hit. We are delay from the test variable 1 to test variable 2. We are calculating the delay from test variable 1 to test variable 2. And it's also the same for this, test variable 1 to test variable 2. The difference is that the formula here is shortened, or the formula here is longer. So the shorter code will actually run faster because we have simplified things. But for the longer code, it's easier to understand in terms of mathematics is easier to understand. Of course, we want to use a faster code. So now I will copy the sketch into here and run. Now we want to calibrate the stroboscope. We click the serial monitor and we see the time. As the time goes, it is actually averaging all the value. And you see, you take the more common value. The last value is the best. Wait for it to stabilize first. It's maybe about 9.13, 9.12. So we'll use 9.13. 9.13 is actually the delay for this part of the code. 9.13. You want to change this to 9.12 or 9.13. So if you change to 9.13, what will happen is that for every 1 second, the LCD will refresh one time. But if it is not 1 second, the LCD will have no delay, right? If you don't put this code, there will be no delay. So it will result in a wrong timing. Therefore, we have to put the delay 9.13 here. If it is reading, in refreshing the LCD, it takes about 9.13 milliseconds. If it's not refreshing the LCD screen, it also take about 9.13 milliseconds. So this is what we want to calibrate here. 9.13, we do not have to update in the sketch. We just key in here 9.13. Everything will be updated in the new code. Now we want to calibrate the second thing, which is to measure the entire code execution latency. Now we off this and we on this. Copy the code and paste into this Arduino. Upload it. After uploading, we click serial monitor. Okay, now we observe the timing. This millisecond delay is actually the time taken for Arduino to read from the start to the end, all the way, the code all the way. So we're measuring the entire code delay, which is about 9.5 seconds. This delay actually affect the RPM, the Hertz value. See here, a little delay is very time sensitive. A little bit of delay will affect the RPM or Hertz. So we don't want this delay to affect, and therefore we plug that average value here into the formula here. The value calculated is about 9.47, so we will put 9.47 here. Now we have calibrated the stroboscope, and beware that if we calibrate using the AVR code just now, we cannot copy this code and run because it will be different value. This code is lower, and we will be expecting about 10 milliseconds for this code and about 9.13 milliseconds for this code. They're different, so we cannot calibrate and use this code as our final codes. LED on-time delay. LED on-time delay, if we decrease the value, we will decrease the brightness. However, we increase the resolution, which means that when we want to do scanning of the RPM, it will be clearer. We will be able to see the rotor moving and the clear image of the rotor. Okay. If we change the time here, it's possible to change, but default is 1000 microsecond. So if we change to 2000 microsecond, it will give you a remark. The default values of LED on-time delay is 1000 microsecond. Changing it may affect the resolution. So if we put it as 1000, we have tested and 1000 is the best value. It's good to go. So good to go means that you can copy the code. What happens if we want to calibrate both at the same time? We put both on time, right? If you want to calibrate both at the same time, no. It will give you a message that says, do you want on calibration at one time to ensure high accuracy? So we do not want to do both job at one time. We do it one by one. So if you want to change this timing, possible. We'll give the message. The remark is to warn people that maybe they have some error in their code here, in the input here. So you can actually change the name of the startup delay name. If I delete, what happens is that ensure that the startup display name is defined. Of course, you have to define, maybe you put something like project 1, or we can also put Stroboscope. The LCD will display Stroboscope for the startup display before it runs the Stroboscope. This is how it works. If you want to use more LED, you can increase the number of output, increase the number of pin. However, this will make these two code different. Of course, the right hand side code is better, a lot better. As you can see here, the digit right 5, 6, 7, 8, 9. If you have so many LED here, you're on 5 first, then on 6, on 7, on pin 8, on pin 9. This means that all the pins will not be on at the same time. It will on one by one, which is what we don't want. So this code is actually better because it turn on all the port at one go. It turn on all the port at one go. 5, 6, 7, 8, 9 all turn on at one go. So it's better. This code is definitely better if you're using all this for output. But for today, we will be using just the number 8 for output. We only have one LED lamp. And even if we have a lot of LED lamp, we can connect it by parallel circuit. It's possible. And we don't need so many output. Okay? So, remember that all the red color highlighted text, all the red text are by itself. You cannot go and amend it, like put an input or output. This will make malfunction the LED later, so we don't want to on this. Okay, so I have come to the end of tutorial. Hope you enjoyed the tutorial. Thank you.